And welcome to this lecture. So we now know what load balancers are. We know there's three different types of load balancers. So we have our application load balancers, our network load balancers, and our classic load balancers. Application load balancers operate at layer 7. Our network load balancers operate at layer 4. And then our classic load balancers, sometimes referred to as ELB, elastic load balancers, mostly operate at layer 4, but they can do layer 7 when using exported 4 as well as sticky sessions. So what we're going to do now is we're going to go ahead and create a classic load balancer. We're going to go and configure some health checks. We're just going to see how the technology works. We'll then move on to application load balancers and we'll have a quick look at the differences. So this is a lab and you will need to log into the AWS console. Okay, so I'm in the AWS console. Check which region you're in and just go over to EC2. Now, you might remember a couple of labs ago, I had an instance that I stopped because we were taking an application consistent snapshot. To fire that instance back up again, if for some reason you've deleted your instance, just create a new one. And I'll show you what else you should do. So I'm just going to start this instance again. Okay, so my instance is now up and running. Here's my public IP address, and I'm just going to go in and SSH into this instance. Okay, so I'm in my terminal, and I'm just going to type in SSH EC2-user, and then @ and then the public IP address, and then and then my key, which is my EC2 key pair. And I'm now logged into my instance. I'm going to elevate my privileges to root, and I'm going to clear the screen. First thing I'm going to do is just check if the HTTPD or the Apache service is running. So I'm just going to say status. So it is running. If yours isn't running, just type in service HTTPD start. And if you don't already have HTTPD installed, all you need to do is type yum install HTTPD and then yes. And then again, just type service HTTPD start, and that will start the service. And then you always want to just do this. So check config and then HTTPD and then on, and that will just make sure that the HTTPD service starts every time you reboot your EC2 instance. So hopefully you've got HTTPD running now, or you've got Apache running. Just type service HTTPD status just to double check, but it should be running. And then you just need to go over to your var /HTML directory and just type in ls in here. Now, hopefully, again, you should probably have an index.html. If you don't, just create one using nano, nano.html. You can see in here my very simple one that just says hello cloud gurus. And then we're also just going to create a health check. So we're going to call it nano health check.html. And in here, I'm just going to say this instance is healthy. Okay, I'm just going to type it in and hit Control X, yes, and then hit enter. And now we've got two files. We've got our health check and we've got our index.html. Once you've done that, go back to the AWS console. Okay, so I'm back in the AWS console. I'm just going to go down to services and click on EC2. And now we've got our running instance, which we're just logged into. And what we're going to do is we're going to go over here and we're going to go to load balancers and just click in here. And you won't have any load balancers created yet. So here we go, we can see our three different types of load balancers. Our application load balancers, which operate at layer 7. We've got our network load balancers, which operate at layer 4. Then we've got our classic load balancers, which is basically at layer 4, but sometimes a little bit of layer 7, but they're nowhere near as intelligent as our application load balancers. So classic load balancers, you will see in the exam, could sometimes be referred to as ELBs. You can see right here, it does make it very clear that it's previous generation. I think they will start phasing out the classic load balancer questions in the exam very soon and just focus on application load balancers, but we still have to teach it because obviously it is still in the exam. So let's go ahead and hit create. So we're going to call it my classic LB. We'll call it ELB just to be consistent. And then we're going to create it within our default VPC. We want it to be able to serve web traffic. So we want it to be an external load balancer, not an internal load balancer. So we're not going to check that box. We don't want to enable advanced VPC configuration because we're just using a default VPC. And then this is our listener configuration. So what ports is it listening to for what protocol? So it's listening for HTTP on port 80, and then where is it passing this protocol and port to for our instance? Well, it's going to, the instance protocol is going to be HTTP, and it's passing it to port 80 as well. So just leave it all as default, go ahead and hit next. Put it into your MyWebDMZ security group, go ahead and hit next. Ignore this error message. We're just basically saying that it's basically saying you're not using HTTPS, you should use HTTPS. The reason we're not using HTTPS is because we haven't got a domain name registered yet, and we're not using any kind of SSL certificates. We'll do that later on in the course. So right now we go to configure our health check, and this is really the guts of creating your Elastic Load Balancer. So we're going to test this over port over HTTP using port 80, and the ping path, we have an index.html, but we also had a web page called healthcheck.html that we created. And then in here is our advanced details. Now, if you ever forget what any of these mean, just scroll over the little info button. So the response timeout is the amount of time it's going to wait for a response from the health check. And this can be between 2 seconds all the way up to 60 seconds. I'm going to do everything as low as possible, so I'm going to go for 2. Now my interval is the time between health checks. So this here is how long it's going to take to do a health check and wait for a response, and then how long is it going to wait between each responses. So what interval are we going to wait between our health checks? So we can have anywhere from 5 seconds to 300 seconds. Let's go ahead and just put in 5 seconds. Our unhealthy threshold is the number of consecutive health check failures before declaring an EC2 instance as being unhealthy. So in this scenario, basically, we're polling it and waiting for 2 seconds. If we don't hear back from that from that web page, it's going to be fail the health check. Then we're going to wait for another 5 seconds and do it again. And if it fails twice, then it's considered unhealthy. And our healthy threshold is just the opposite. So how many consecutive health checks does it have to pass before it becomes healthy again? So I'm going to make this 2 and 3, and we're just going to keep it quite lean. So it's both going to pass or fail its health checks really, really quickly. I'm going to leave it as 2, 5, 2, 3. Go ahead and hit next. And in here we add our EC2 instance. So we've only got the one right now. So we're going to add our web server to it. Go ahead and add our tags. Now, this is so important, and the most of the time when people go above their free tier account, when they start actually spending money, it's because they've forgotten about their Elastic Load Balancers. Elastic Load Balancers will cost you money if you leave them on, especially if you've got multiple Elastic Load Balancers across multiple different regions, and lots of people just forget to delete their Elastic Load Balancers when they're not using them. So just put in here production ELB, and then value is on, so we know that we've got this particular load balancer on, and then you'll be able to track it using resource groups, which we'll look at in the accounts section of the course. So we'll go ahead and hit review and create, and now we'll go ahead and hit create. So we've created our Elastic Load Balancer. There it is, and it's you can see the type here is classic. It's serving both availability zones automatically. It's in our default VPC, and we're given a DNS name here. If we just move this across, there's a DNS name for our Elastic Load Balancer, and I just want you to copy that into your clipboard, and we'll use that in a second. So let's go down to health check. In here we've got all our different configurations that we just set up. We can edit these at any time. In here we've got our instances. Right now our instance is out of service, so it's not being able to pick up our our web page that it's looking for. Now we'd expect this to come in service relatively quickly. Just hover your mouse over there. If it still says instance registration is still in progress, don't worry about it. You might have to actually wait a couple of minutes because this is the first time you've provisioned your EC2 instance. So I'm just going to pause the video for a second. Okay, and we can now see that it's in service. So our instance count is 1 and it's healthy. It's within availability zone 2A. We don't have any other instances currently available, and we can remove it from the load balancer. What I'm going to do now is I'm quickly just going to simulate a failure. So I'm going to Alt Tab over to my terminal window, and in here we've got our file healthcheck.html. So we could just go rm-rf, so we're going to delete this straight away, and then healthcheck.html. And there we go, it's deleted. Now if we come back here, and it shouldn't take very long, if we go and have a look at the health check settings, so it's going to poll, it's going to wait 5 seconds between polling, and it's going to wait for 2 seconds. So it should take, for an unhealthy threshold, it's going to be 2 times 5 plus the timeout between them. So about 10-15 seconds or so. So let's click back here, and yep, there we go. It's already out of service. And the reason it's out of service is because it's looking for this file healthcheck.html, which we just deleted. So let's go back in and add that. So I'm just going to go echo I'm healthy cloud gurus, and then I'm going to output that to healthcheck.html, and that should create a little web page. There we go. And if we alt tab back into our browser, and then we go over to our instances, we'll just hit the refresh button. I'm just trying to play for time here in case you in case you were guessing. And there we go, it's in service. So it doesn't take very long for it to detect that file go missing, and then to remove that EC2 instance from the Elastic Load Balancer. And that's a really important point. Once an EC2 instance is out of service, your Elastic Load Balancer will not send traffic to that EC2 instance because it's failing the health check, and it's presuming that that EC2 instance has gone down. Now, we cut and pasted the DNS name into our clipboard. I want you just to do it if you haven't already done it. And I've just opened up a new tab here. I'm going to paste it in here, and that's going to point straight to my index.html. So straight away we're getting DNS resolution. It's converting the name of our Elastic Load Balancer to our public IP address, which is going to be this IP address that's attached to our EC2 instance. So it's this one here. And essentially we're then able to view our index.html web page. Now notice that you're going to get a public IP address for your EC2 instance. What you don't get is a public IP address for your load balancer. All you ever get is a DNS name. And basically your Elastic Load Balancer will have a public IP address, but Amazon manage it for you, and they don't want you to ever use public IP address for ELBs. They always want you to use the DNS names. The reason for that is because the public IP addresses can change. So you always use the DNS name for your Elastic Load Balancer. And when we start doing the Route 53 section of the course, I'll show you how to basically point your domain name to this DNS name, and then how to put EC2 instances behind it. So then that way, if you lose an individual EC2 instance, your web page won't go down. It'll just take that EC2 instance out of service, and there will be other EC2 instances in service that you can navigate to, so you won't have any kind of downtime. And we're going to do that in a lab as well, which appears later on in the next section, or in a couple of sections in the course. Okay, so we're quickly going to create the second type of load balancer, the application load balancer. You can see it here. So we just did the classic load balancer earlier. We're not going to do a network load balancer. It's beyond the scope of this course. We do have a dedicated course to application load balancers. It's a couple of hours, and it's on the A Cloud Guru platform. So if you want to deep dive into application load balancers, make sure you do that course. So let's go ahead and hit create. And in here, I'm just going to give it a name. I'm going to call it My Application ELB. I should probably call it ALB, but I'm so used to saying ELB, I may as well call it that. Then in here, we've got whether or not we want it to be internet facing or internal. I'm going to have it as internet facing. Here's our listeners. We're just going to do it on HTTP. Down here, we've got our availability zones. So these are our available subnets. Remember, I always say this, one subnet equals one availability zone. You need to remember that going into the exam. So we just go in here and we add them in. So now we're going to be load balancing across EU West 2A as well as EU West 2B. And if you're in a region with more availability zones, just add in all the ones that are available to you. Go ahead and hit next. For security settings, we're just going to be using HTTP. We're not going to be using HTTPS, so go ahead and hit next. In here, we select our security group, so MyWebDMZ, hit next. Now in here, this is where we create our routing, and we use what's called target groups. So I'm just going to call this My App ELB TG for target group. And that's going to be the name. We're going to create a new target group because we haven't created a group before. And then I'm going to do HTTP over port 80. If I change this to HTTPS, it's going to update the port to 443. In here, we've got the health check. So what protocol are we doing the health check on? Well, we're going to do it on HTTP. And then the path, well, we called it healthcheck.html. In here, we've got our port settings, so you can say on the traffic port, which will automatically go to this port here. So if it's 80 for HTTP or 443 for HTTPS, you can also override it, so you can tell it to send or do a health check over on a specific port that you want to specify. So in here we have our healthy threshold and our unhealthy threshold. So this is the number of consecutive health checks before it's unhealthy, and then this is the ones before it's healthy, and this is unhealthy. So let's say 2 failures, we'll take it out of service, and in here let's just say for argument's sake as well 2. Our timeout is the time in seconds where no response is is going to be a failure. So I'm just going to put this as 2. And then our intervals I'm going to put as 5 seconds. In here we've actually got HTTP codes that we can specify as a successful response from the target. And you can have multiple values, so it doesn't just have to be 200. It can be 200 to 202, or we can do a range. So let's do 200 to 299 just for fun. Go ahead and hit next. And now we're going to register our targets. So all we do is we click in here and we hit add to registered, and we're doing this on port 80. So we're adding this EC2 instance into our registered targets. We go ahead and hit next, and we just review everything. All looks good, and go ahead and hit create. And that will now create our application load balancer. So we've got 2. We've got our classic load balancer and our application load balancer. I'm going to pause the video and wait for this to come live, and then we're just going to go in and test it. Okay, so I'm just going to refresh the screen, and there we go. It's gone from provisioning to active. So this is my DNS address for my application load balancer. Just like with classic load balancers, you're never going to get an IP4 address for your application load balancers. You're always going to be using the DNS address in order to connect to it. And we can go down and have a look at our listeners. We can see here that it's just listening in on port 80. And then we go down to monitoring, and we can see our different monitoring statistics in here. Here we can track the number of HTTP errors that we've got. So we've got our server-side errors here. We've got our client-side errors here. So this would be like things like 404, etc. And then we can scroll back up. If you want to make this a bit larger just to have a look at it, you can. And then we've got our tags in here, but I haven't added any tags. Now, what I want you to do is just grab the DNS name and copy it into your clipboard, and then open up a new tab, and we can see it here. Just hit paste, and you'll be able to see, there we go, Hello Cloud Guru. So our application load balancer is working as well. Now, we do have a full, very big deep dive course on application load balancers and how to use them. So that is available on the A Cloud Guru platform if you want to learn a bit more about it. Okay, so what are my exam tips? Well, when it comes to load balancers, remember there's 3 different types of load balancers. We have our application load balancers. They operate at layer 7. Our network load balancers, which is where you want super fast performance at layer 4. And our classic load balancers, sometimes referred to as elastic load balancers. They still do feature in the Solutions Architect Associate exam, so you will see questions on them. And they mostly operate at layer 4, but they can do some layer 7 routing, but they're nowhere near as intelligent as our application load balancers. Remember that when you get a 504 error on a classic load balancer, it just means that the gateway's timed out. This means that something in the application is not responding within the idle timeout period. And what you should do is go ahead and troubleshoot that application. Is your web servers down, or is your database server down, etc. And if you need the IPv4 address of your end user, you just need to look for the x-forwarded4 header in the classic load balancer or elastic load balancer. We also learned that instances are monitored by ELB are reported as 2 different types. So we've got in service or out of service. Your health checks just check the instance's health by talking to it. All load balancers have their own DNS name. You are never given an IP4 address or an IP address even for any load balancers. So Amazon do all the management of the DNS for us. And then just go ahead and read the Elastic Load Balancer FAQ for classic load balancers. It really is worth a read because you are going to get tested on it in the exam. And if you want a deep dive on application load balancers, then check out our deep dive course on the A Cloud Guru platform. Well, that's it for me, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you.